Let me see if I get sound from here. I don't. Oh, yeah, there it is. So, welcome to Helsinki. Lovely place. I'm really happy to be here today. And today we're going to be talking about music. And what I like to do is I like understanding the world through Ruby. You know, the world is a really big, complicated place. And you know, we are programmers, so we can use the language we like to just understand things a little bit better. And you know, once you can write some code for something, you sort of actually get what it's all about. So that's what I did with music stuff. So I've been like making music as a hobby for a long time, and this talk is sort of the intersection between my two main interests, which is programming and music. And this is what I like to do. Like, don't understand it, you figure it out through writing code, and then now I'm here and I'm showing this stuff to you all. So we're going to go over a few things today. So we're going to do a really brief history of recorded music, and I'll show you how technology really played a big role in making that whole thing happen. Then we're going to look at what digital audio actually is and how we can visualize it, and we're going to do a few mixing tricks, and we're going to make some actual sounds. And there's a whole bunch of code, Ruby code for this talk, which you can find here afterwards. So you can kind of play with it if you're interested. So we'll get started by talking about what audio in the end actually is. So audio is a waveform, and we perceive that as having and to make that audio, to turn it into music, our brain uses pitch, timbre, and tempo to kind of create this illusion of music. So this is like a sine wave. So this is a waveform that doesn't exist in nature that often, but it's the most simplest thing that can have a pitch. And a waveform is actually quite similar to what you would see in a pool like this. It's kind of waves of air molecules kind of like bouncing against each other and making their way through a space like this one. So these bouncing air molecules, they're coming out of the speaker here at the moment, and they're kind of creating a chain reaction of air molecules all bouncing against each other in a wave. Eventually, they end up in all your ears. And in your ear, there are actually a lot of like little hairs called hair follicles, and they vibrate in response to what these air molecules do. That creates a little electrical signal, and that signal makes its way to your brain. And your brain magically creates meaning out of these vibrations. So humans are capable of doing language and interpreting audio waves as music, and the scientists haven't really figured out how this works yet. So I don't have an answer for you there, but somehow some magic happens in all our heads, and this music thing that most people love just appears. So how does the brain do this? In three different ways. So the first way is pitch. So pitch is the number of times that a wave like this oscillates. So this is a pitch. You know, the most boring one that you can come up with. This is just like a number of oscillations per second. And if you do different types of different numbers of oscillations, you get a scale like this. Yeah. So we already we all got this in primary school, and this is simply the same waveform, but just like happening more often than one of the other ones. The second thing that our brain uses is timbre. So timbre is about timbre is what makes a sound like a violin sound like a violin, for example. So that would sound something like this. So this is all one pitch, and there's a whole concert just playing, creating a lot of like little variations within a waveform that just create more of an atmosphere, if you will, and are also a big part of music. And the last thing is tempo. So if you just do some sound sources and you put a little break in between them, we perceive that as a rhythm. And if you combine those things, you get like a little piece of really simple, but it is music. So I think this is a really simple like piece like this. It's basically nothing, but you already have all the components in place. And back in the day, music was always live, but then we got technology. So in the past, people just used to play around a campfire or something, and it would actually be like a communal activity. So everybody would join in and sing a little. And we kind of lost that through this process of moving everything into recordings. So these, this process really started in the early 20th century. So there's this guy called Thomas Edison, which you've probably heard of. He invented like a lot of stuff. And one of the things he invented was this machine called the phonograph. So this would, if you shout really loud into that hole, it will, a little stylus vibrates, and it makes a little etching on that cylinder. And that sounds like this. It's quite, it's like not a lot of fun. And this thing actually never made it, and that's because Edison patented it. So I think there are a lot of these kind of like technological things kind of echo through the ages, because it was patented, nobody could use the technology except for him, and nobody wanted to pay him a license fee. So this other guy, he was called Berliner. He came up with this phonograph concept, which is disc. So this is how we ended up with discs. I guess if Edison wouldn't have patented his machine, we would have like been walking around with cylinders for 100 years instead of flat discs. And the phonograph like started to sound a little bit better. Still not really a lot to write home about. So then we're kind of like getting into the nicer stuff. So the tape machines like actually sound pretty good. And yeah, that's the tape machine. Then the Second World War happened, and then the developments really accelerated quickly. So we got like tubes, and people like started making like really good microphones, and they started doing like multi-track recordings. So this is the Beatles with a lot of different mics. You got mixing desks and like transistors. Now then we got to the 80s, and everything became digital. We got CDs. For the younger people in the audience, you know, this also used to be something that you would play music from. And eventually, like everything moved into computers, and that kind of brings me to the point of where I'm here today. You know, people nowadays use software like this to make music, and we're going to like take a few components out of this program called Ableton Live and just recreate it in Ruby now. And to be able to do that, we first need to understand what digital audio actually is. So digital audio is a lot of samples in a row. So if you take this waveform, if you look at the little like edgy points, that's all the points where a sample is being taken. So it's basically just measuring how the intensity of the waveform at a given time, like thousands of times per second. And if you like recreate a waveform out of that, you get something that's so close to the original that you really can't hear the difference if you're a human. So we got a lot of numbers. And these numbers can be positive or negative. So this waveform is kind of like going up and down, and it's kind of going around the zero all the time. And the simplest format for audio is the wave format, and there is a gem for that can read that. So I'm using this gem to read the wave files and kind of like process them, and then we write them back to disk, and we can do some stuff with them in Ruby. So this is some code some helper code that we need to kind of just read the wave file and just like make one really big array out of all the numbers in the audio. And once we have the big array, we can do some stuff with it. So that looks like this. So this is probably like a second of audio, something. There's just a vast amount of numbers, and it's way too much for us to make any sense of it just by reading them. So we're going to need some visualizations. So we'll make some PNGs. And we also, in the Ruby ecosystem, we have a great gem to make PNGs, chunky PNG. And we're going to use that to create some images. So we're looping through all the samples here. And for every sample, we're going to like draw a little dot on a PNG image. And it's either going to be like on the top half of the image or on the bottom half of the image, based on if it's a positive or a negative number. So this code generates images like this. So this is like some real-world audio. I think this is like some like a car passing by or something. This is like pretty random stuff. There's a lot of these little dots. But if you visualize a sine wave like this one, it actually looks like a mathematical function. So the only thing is this image we're looking at now is maybe like 10 milliseconds of audio. There's a lot of like these samples going on. So we need a way to kind of like compress stuff so we can look at a whole minute of audio in one overview. So we can use the Ruby enumerable method for that. We can use each slice to just get slices of data, and then we kind of aggregate those together to create a more comprehensive image. So that's what we're doing here. If you want to check out this code, it's a little complicated. Definitely look at the repository. But then we end up with images like this one. And if you ever work with any digital audio, you're probably familiar with what this one looks like. So this is sort of like our way in. So now we can see some stuff, and then we can start listening to some stuff as well. So the first thing we're going to do is we're going to make some audio louder, just to kind of start with the simplest thing we can. So if we take a little waveform, like for example this one. This is a little drum loop. Oh, sorry. So we got a little drum loop here, and we actually want to make it louder. So we want to, if you compare these two images, you'll notice that the peaks are kind of going up. So the higher the peaks are, the louder the audio is going to be. So we got a little higher peaks here, and that sounds like this. Yeah, so it's the same thing, only louder. And how can we achieve this? Well, we just have to multiply all the samples with some kind of other number. So if we want to make the whole thing twice as loud, we can just loop through through all the samples, multiply them with the ratio, and then rewrite that back to disk, and then we end up with a louder thing. And there is an issue here potentially, because if you multiply it with a ratio where it's actually louder than what the whole range of numbers can be, you get a result like this. So we're getting like a heavily distorted sound now, and audio engineers call that clipping. So it actually cuts off like part of the waveform at the top, and you get this ugly distortion. And you can see that here, that like actually the loudest parts of the signal are actually out of range of the image here at the moment. So they're being cut off, and then because they're all sort of like the same at the top, you end up with this distortion. And that's also the basic principle of how distortion works. So if you like listen to like metal, I guess we're in Finland, so I should talk about metal. If you listen to metal, there will be a lot of distortion, which basically follows this principle, only in a like more aesthetically pleasing way. So the next thing, like you'll hear on every record, is mixing. So mixing sound sources used to be done by kind of like taking electrical currents and kind of mixing those up. But in the digital world, we can do this as well. And what we do then is we take multiple channels, and we kind of combine those into one more complicated waveform. So these are some of the samples we'll be using here. And the way we do that is we simply read all the audio for like this bass, this drum, and this piano track. So we have like 3 samples of the exact same length that start at the same time. And we can make a really little small mixer in Ruby by looping through the first track and then taking like data from the other tracks and just summing that up. So we just simply take like every single number, we add those up together, and then we end up with a mixed result. So this is actually a mixed sound in Ruby. Yeah, so we're doing really almost nothing here, and it just works. And I think that's kind of like the magic of this audio stuff, that if you really get down to it, there's not really much there. While people sometimes pretend that there is like a lot of complicated stuff going on. So the next thing we're going to talk about is compression. And compression is a way of making things sound louder by actually making them less loud, which sounds like a paradox, but I will explain that in a minute. That used to be done with like these analog machines as well. So if you have a signal like this, and there are some peaks in it, those peaks are actually preventing you from making it louder, because if you would make everything loud, you would get the clipping thing that we just talked about. And you would get distortion. So you actually need to find a way to make these peaks less loud, so that you can sort of like bump up the signal of the whole thing. So the way that works in the audio world is that you pick a threshold, and you only make things that are higher than that threshold. You kind of select out the things that are higher than that threshold. And the next step is to only make those parts of the signal less loud. So you're bringing down those peaks, and once you brought down the peaks, you can like move the whole thing. You can amplify the whole thing again in the second pass. And this is like the basic thing that's used in recordings just to make things sound loud. So if you look at if you listen to something like Daft Punk, they will use this like very intensively to create the effects that they want. And we can also do this in Ruby. So say we have this little piece of audio. It's like a cymbal hit. We can use some Ruby code to do this compression trick. And we actually need 2 steps here. So the first step is identifying samples that are above the threshold, and then we're bringing the volume down. So again, we're looping through the whole track, doing all the samples. And we're selecting, with this if statement, we're selecting the samples that are above this threshold, and then we're just making them a little less loud using this ratio. So that's pass number 1. You know, the peaks are kind of like brought down. And to make the whole thing louder, we're doing the exact same thing that we did before with the amplification. So we're just multiplying all the samples with this extra step. The audio engineers like to call this makeup gain. I'm not exactly sure why, but that's their term. And then we combine those 2 steps to create our compressed sound. And that brings us to, we had this thing. And I believe I have made the worst sounding compressor that exists on the planet, and you will hear it now. It's not pretty. So we're going from this to this, and it sounds like this. So if you might notice like the ringing that goes on. So like the initial hit sounds just about as loud, but then you kind of like get this really long tail end of just like a weird like ringing sound. And maybe I should sell this thing. It could be like it could be a genre in 5 years or 10 or 20. Who knows? So that's sort of like the mixing part of things. So next up, we're going to like dive into like some ways of actually making sounds. So Back in the day, and actually still now, these things still are used on a lot of records. They sound amazing. Like people use these analog synthesizers to make sound, and they had like electrical circuits that can generate waveforms. And nowadays you can obviously also do that with a computer. So there's three ways actually in which synthesizers like this make sound, and we're going to like quickly cover those. So the first thing you can do is make noise. And making noise in Ruby is not really hard. You just have to use random. So we're giving the random function a range here, like from minus 30,000 till 30,000. So we're just getting random dots on the whole thing within this range. And the visualization of that looks like this. It's as random as a computer can be, and that sounds like this. Yeah. So that's some real like Ruby generated noise we got there. And you might ask yourself, like, what's the point of like having a synthesizer make noise? And the reason it's in there, or at least what people ended up doing with it, is that it's used for percussive sounds and snare drums a lot. So if you kind of like just cut off and if you kind of like introduce pauses within the noise, you sort of like get a percussive sound like this. And then yeah, you got some real like Ruby generated snare drums there. And the next thing a synthesizer can do is generate a square wave. So a square wave is, like as the name implies, a wave that's square. And to make a square wave, we need to create something, we need to replicate something that's called an oscillator. So an oscillator comes from sort of like the name comes from the electrical side of things, where like something would generate electrical current in a kind of pattern. So we're doing that in Ruby here. So we create a class, we include the enumerable method, so it's easy to do things with it later. And then we've got the each method at the bottom. So if you create a class, include enumerable, and just have a def each, you can do like all the nice things with it that come with the territory. And what we're doing is we're yielding next sample anytime like the loop is called. So and next sample just returns either like a high or a very low negative number based on the position that it's in at the moment. So we're getting like a number of like 20,000s in a row, and then we're getting like a number of minus 20,000s in a row. And if we use that oscillator in a loop, then we can generate some sound again. So we can just use each with index here because we included enumerable, so we can do all the nice stuff with it that comes with that territory. And we're just getting the next values from that oscillator and adding them to the piece of audio that we're creating. And then you end up with something like this. So we've got a whole bunch of like dots at the top, a whole bunch of dots at the bottom, and then you get something that sounds like this. Yeah, it's quite ugly, but it is actually like the foundation of like a lot of electronic music you probably listen to. So they do all kinds of processing with it, which I'm not getting into today. But this is sort of like one of the fundamentals. Another fundamental is the sine wave. So a sine wave is a wave that's a pure sine. So you can make it by using a circle, which we will do in a second. And the sine wave sounds like this. So it's kind of like it has a very distinct sound as well. So the way we make a sine wave is we're creating another oscillator. And in this case, we're actually using the position together with pi to find the position. We're basically emulating what's happening in this visualization here. So we're using the position. We're using pi to get the position of the circle for this given position, and then we get like the next sample that will form the sine wave if we combine it. So a sine wave looks like this. I just already played it. And next up, we can combine some oscillators to create a chord. So a musical chord is a combination of of sounds with different pitches, and they kind of make up a more pleasing sound together. So if we take these three oscillators and we combine those two with the mixing trick we did earlier, we get something that sounds like this. So this is kind of like playing multiple strings on a guitar, just by adding up those samples. And the visualization of it ends up being like a lot more complex. You can kind of see like different. This is actually the combination of three different sine waves being merged together. And if you want to get more into that, I think like one super relevant thing that's used in music a lot, and also in a lot of programming, is the Fourier transform. So this person called Fourier came up with a theory that all waves that exist in reality can be recreated by combining multiple sine waves. You can see an example of that here. And if you're like do anything with data analysis or like signal processing, this is like a super relevant thing to look into. It's a bit like the actual math behind it would be a talk in itself, so I'm not covering that today. But it's definitely super interesting to take a look at. And the last thing I have for you today is like doing timbre with a synthesizer. So one way to do that is to create both this sine and this square oscillator that we made earlier and combine those two sounds together. So if we again do the mixing trick, we end up with this weird-looking waveform, which sounds like this. Also not very pretty. Like I think I'm making some really ugly sounds here today, so sorry about that. But we just made a timbre just by writing some really simple Ruby code. And that's almost what I have for you today. But I think like I see some skeptical faces here in the audience. So I wanted to prove to you all that you can actually make music with this stuff. So I created a cover of, I believe, the best song ever made. And I'm going to play that for you now, and then I'm finished. Thank you.
It's pretty difficult to take the floor after. Guys, please stay with us. Thank you so much. Quite a few questions. Please vote. You'll get answered what you want. The first question here is from Loudness Warrior. Excellent. How do you sidechain your kicks to your bass?
We're using Ruby.
Okay.
I could have made that. Like, well, sidechaining is a thing where you do compressor, but you kind of use use the signal from a kick drum, for example. And probably too much detail for this. So Loudness Warrior, come find me at the party.
Yeah, otherwise we go with Motorhead, everything louder than everyone else. Excellent. Are there any common misconceptions about audio or music that annoy you? Is there something that...
I think the primary thing is that like the actual real musicians all pretend that it's like a super esoteric, complicated thing. Well, actually, they all know it's really simple math. They're just like making a really big show out of it, and I guess that kind of annoys me.
Excellent. Yeah. So you don't have to learn how to play guitar. You can make music with Ruby, right? Can we play with vocals with Ruby?
With vocals?
Yep.
Sure. Yeah. You can take the code from this thing and just like apply any audio you like.
Excellent. That was from Yara. And from Nora. How are overtones created and or visualized?
Yeah, that would be another kind of complicated thing to dive into. So an overtone is when you have like a pitch, and then like in a real world, it will kind of like other things would also vibrate, and that can create like extra pitches on top of that. And you could make it in Ruby, I'm sure. I haven't tried that.
I have to say, this is one of the occasions where I really feel like a talking head, because most of the questions that I'm asking, I have literally no clue. How would you apply attack/release time to your compressor? Excellent question. Thank you.
I intentionally left it out because I actually I wrote a version that does attack and release. So attack and release is where you kind of try to see if the things that are over the threshold are staying over the threshold for a longer time. But it was getting so complicated that I decided to just not do it.
Have you tried Sonic PI, and what do you think is the future of music in Ruby?
Yeah, so there's this program called Sonic Pi, which is really cool. It's you can use that to like make actual songs in Ruby with using loops, and it's an amazing piece of software. Definitely try that out. And I've tried it a little bit. It's really amazing.
And question from the same person called Anonymous: how would you write tests for it?
No comment.
Thijs, keeping it, respecting the schedule, and also we're heading to lunch in a bit. Thijs, thank you so much.
Yeah, thank you. Yeah. Thank you.